Today we're going to talk about the surface area and volume of spheres, and then we're also going to talk about composite surface area and volume. So let's start with spheres. So a sphere is the set of all points in space that are equidistant from a given point. Now the point is called the center of the sphere. Now a segment from the center to a point on the sphere is what we call a radius, and then the diameter goes through the center of a sphere. So here we can see in this first picture, the center is at C, and we see the radius, which is drawn from the center to some point on the sphere. Here we can see a diameter, so that goes through the center of the sphere, and then a chord is just connecting any 2 points that are on the sphere. Now let's talk about surface area. So the surface area of a sphere is given by this formula here, 4 pi r squared. So you only need to know the radius of that sphere, and then you square it and multiply it by 4 pi. Take a look at example 1. So you're given a sphere of radius 8, and you're trying to find the surface area of the sphere. So this would be 4 pi times 8 squared, and that comes out to be 256 pi. Now that would be an exact answer. If you were asked for an approximation, you would say this is about 804.25 square inches. Okay, example 2. The surface area of the sphere is 20.25 pi square centimeters. What is the diameter of the sphere? Now for this problem, we're going to need to work backwards. So let's start with the formula for the surface area of the sphere. Now we're told that the surface area is 20.25 pi, and now we can try to solve for r. So we can divide both sides by 4 pi, and then take the square root of both sides, and we get r is equal to 2.25. Now the question is asking, what is the diameter of the sphere? So we're going to need to take this radius, 2.25, and multiply it by 2 to get us 5.5. So our answer is C, 5.5. Okay, now we have another term when it comes to spheres, and it's called a great circle. So when a plane cuts a sphere exactly in half, it creates a great circle. The circumference of that great circle is what we call the circumference of the sphere. And this great circle divides a sphere into 2 hemispheres. It divides it into 2 halves. So here's a picture. You can see that plane that cuts the sphere in half, and that cross section there you see is a circle, and we call that a great circle. And we have 2 hemispheres, one on top of that plane and one below that plane. Alright, now let's talk about the volume of a sphere. So we talked about surface area, that's 4 pi r squared. Now the volume of a sphere is given by this formula here, 4/3 pi r cubed. And again, we only need to know the radius r, and that will give us the volume, 4/3 times pi times r to the 3rd power. Look at example 3. The soccer ball has a diameter of 9 inches. Find its volume. Okay, since the diameter of the ball is 9 inches, that means that the radius is half of that, so that would be 4.5 inches. Now you can use the formula to find the volume. That would be 4/3 pi times 4.5 to the 3rd. And then let's simplify that as much as we can. So we have 121.5 times pi. And multiplying that, we get 381.70. So the volume of the soccer ball is about 381.7 cubic inches. So that's all we have on spheres today. So we talked about surface area and volume of spheres. And now we're going to talk about what we call composite solids. Now, as the name suggests, composite solids are solids that are made up of 2 or more basic solids. Now, to find the surface area of a composite solid, you would find the sum of all the exposed surfaces. And then for volume, you would find the volume of all the included solids. Let's go ahead and look at an example. Find the surface area of the solid below, round to the nearest hundredth. Now for this example, you can see that we have a cone, and then on top we have what looks like half of a sphere. So to find the surface area here, we're going to first start off by finding the surface area of the cone. Now in this case, to find the surface area of the cone, well, we only want the exposed parts. So in this case, we only want the lateral area of the cone. That's going to be pi times r times L, where L is the slant height. Now we have the radius r, 4.9, but the slant height we don't have. How do we find the slant height? Well, because we are working with a right circular cone, that means that we actually have this height given to us that will be helpful. That's 12.6. And we can use that to help us use the Pythagorean theorem to find the slant height. So you would do 4.9 squared plus 12.6 squared, and that would be equal to c squared. And whatever c is, that's your slant height. In this case, it would be 13.5. So this is equal to pi times 4.9 times 13.5, and that comes out to be about 207.82 cubic centimeters. Alright, now we need to find the surface area of the hemisphere. Now the surface area of the hemisphere is going to be half the surface area of a sphere. So 1/2 of 4 pi r squared. Alright, now we can plug this in. So we have 1/2 4 pi times 4.9 squared, which is 150.86. And now to find the surface area of the entire solid, we're going to need to add those two together. So 207.82 plus the 150.86, and that comes out to be 358.68. So the surface area is 358.68 centimeters squared. Alright, example 5. Find the volume of the solid below, round to the nearest hundredth. Now we see here we actually have a cylinder, but there is a portion that has been taken out that is in the shape of a hemisphere. So the volume of this solid is going to be the volume of the cylinder minus the volume of the hemisphere that has been taken out. So the volume of a cylinder is pi r squared h, and then the volume of the hemisphere, that's 1/2 of a sphere, so 1/2 of 4/3 pi r cubed. Now we see here that the radius is 2, and the height is 2, so we can go ahead and plug those values in. So that'd be pi times 2 squared times 2, minus, and then the 1/2 times 4/3 becomes 2/3, and then pi times 2 to the third. So that's going to come out to be 24/3 pi minus 16/3 pi, which is 8/3 pi. So the volume of the solid is 8/3 pi, or if you multiply it out, it's going to be about 8.38 cubic inches. So when it comes to finding the surface area and volume of composite solids, you always want to look and see for surface area, what are the exposed surfaces that I need to find the areas of, and for volume, what are the volumes and how do I add or subtract them to get the volume of the solid that I'm looking for.